Alright folks, welcome to Yak Math Videos for your Stats Chapter 13 quiz review video. Your quiz is this Wednesday, the 17th. Today we are brought to you by Chinatown, Coffee Espresso, Ruby Tuesdays, the lovely Wang Gang in Edwardsville, Crazy Bowls and Wraps, Starbucks, Tazo Tea, and our new sponsor, Adidas. Nothing says mediocre shoes at a very nice price, like Adidas. We thank them. All right, folks. Taking a look here at numbers 1 through 4. Let's see. We are using the binomial distribution here, and folks, here is a rough draft of what I will give you formula-wise. This is the binomial distribution. Okay, might mention that it is the binomial. You're gonna have to know how to use it. Next, we have the geometric, when you want to succeed one time and fail all but once. Next, we have the Poisson distribution. All right, followed by, this is the normal approximation for the binomial. All right, that's how we get our mean and our standard deviation, and that's how we get our z-score. So all of this will be presented, given to you for your quiz on Wednesday. All right, folks, this matches your homework pretty well. So you have to tell me in all these what X is. X is a battery that lasts 18 months. And what we want here is the probability that X is greater than or equal to 13. So that means 13, 14, and 15 of them last 18 months. All right, folks, 15 choose 13 times. I want 13 of them to be successful. That's 0.18 to the 13. Then the probability of not being successful, the battery not making it, 0.19 squared. Anyway, let's keep rolling through here. That is 15 choose 14. All right, so I want 14 of them work, one not to make it, that is. If I want all 15 of them to last 18 months, then that is 1/8 to the 15th. All right, that's my answer. Less than 12 of the batteries last 18 months. So let's think about that. That means really 1 minus 12, 13, 14, and 15 of them lasting. Well, lucky for us, I already have the probability that 13, 14, and 15 of them last. So I really just need the probability that 12 of the 15 last 18 months. So I find that probability, and I add that probability to my previous answer and subtract from 1. All right. 11 to 13 exclusive of the 15 batteries last 18 months. So the only new number I need there is 11, because I already have 12 and 13. 12 and 13 from the previous one. So that's the probability that 11 of them make it. So add up those three numbers, and that's what I get. All right, the probability that a component will fail after first usage is 0.04. 25 of these components are about to be used for the first time. Find the probability that no more than one of the 25 components fails. So a probability that X is less than or equal to 1 is probability X is 0 plus probability X is 1. So if I want all of them to not fail, that means 0.96 to the 25th power. If I want one of them to fail, that's how I would write it. All right, add them up. There we go. 0 to 2 inclusive of the 25 components fail. So I already have 0 and 1. Let's find the probability that 2 of them fail, which is that 1/88. Add it to my previous answer, and there it is. All right, those two are binomial distribution questions you should expect. Here's another one. A pitcher gets a batter out with probability 0.79. The coach will let this pitcher face 25 batters this game. Find the probability that no more than 3 of the 24 batters get on base. All right, so if I want 3 or fewer batters to get on base, then I'm going to let X equal a batter getting on base. So the probability that a batter gets on base is not 0.729, it's the complement, 0.271. All right. So if I want all 24 of them to get out, that's 0 batters on base. That's 0.729 to the 24th. Basically 0.001. That's how it would round. And we rounded it like that at the end. All right. 24 choose 1. I want one of them to get on base. 23 to get out. I want 2 of them to get on base, 22 of them to get out. And lastly, it's down right here. I want 3 of them to get on base, 21 of them to get out. So those 4 situations, add them up. And it's 0.078, I believe. That looks good. All right, between 5 and 7 inclusive. All right, so that's probability 5, 6, and 7 all added together. That's 5 of them getting on base, 6 of them getting on base, 7 of them getting on base. So that has just above a 50% chance of happening. All right, 6 or more of the 24 batters get on base. 6 or more means everything but 5 or less, which I have all of those except for 4. All right, from the previous ones, I have 1, 2, 0, 1, 2, 3. I just found out the probability of 5. So I just need to figure out the probability that exactly 4 batters get on base. That's 103. Add them together and subtract from 1. All right, again, pause this whenever you need. I'm going to try to speed this up so it can just be one video. Our favorite player, Palmer Cress here, 83.6% free throw shooter. Probability of success is that. That's the number of observations in. Let x be the number of free throws he makes. Find the mean and standard deviation of x. Okay, the mean is n times p. Standard deviation is in the square root, n times p times 1 minus p. Again, 1 minus p is also known as q some places. All right, standard deviation of 6.08. How many, using the 2 standard deviation rule, how many free throws should Palmer Cress expect to make? That is the mean plus or minus 2 standard deviations. And that is our answer. That's a pretty easy question there. All right. Also brought to you by HP affordable computers at a somewhat okay performance. A final year undergraduate will pass a certain certification exam with probability 0.842. 300 final year undergrads will take the test. Again, we'll find the probability. All right, so this is the normal approximation. I got to figure out what m is, the mean, 252.6. That is the standard deviation. So z equals x minus the mean over the standard deviation. You get a z-score of negative 0.41. You look in your z-table. Negative 0.41, that's the area with it, 0.3406 or 09. I want at least, so greater than or equal to that, so I subtract that from 1. No more than 240, that means less than or equal to 240. I do 240 minus the mean over my standard deviation. Get a z-score of negative 1.99. Less than or equal to that means I keep that area that z-score tells me, 0233. All right, and then between those two, that means I need 2 z-scores. My lower z-score is that, negative 0.73. The area that corresponds with that is 2327. And then my bigger z-score is 0.54. The area that corresponds with that is 0.7054. I want to find the area in between. That's the probability that I will have between that many students, and that is subtract those two, and we get 0.4727. All right, a certain medication cures. So again, up above, X is a student passes the exam. All right, here X is a patient has their symptoms cured. All right, to figure out the mean, just do n times p. There's a standard deviation. All right, I want more than or equal to 140. The z-score is 0.52. All right, since I want greater than that, I got to subtract it from 1. Less than or equal to 130. Z-score is basically negative 1. I want less than or equal to that, so I keep the area that the z-score gives me in, I'm falling off here, in that example. All right, moving on here. Our man, Willie Deckham, 309 hitter. He will get 150 at-bats this season. Find the probability that it gets between 45 and 50 inclusive. So again, got to figure out what my mean is. Got to figure out what my standard deviation is. All right. And I do 45 minus 46.35. That's my z-score. 50 minus the mean over standard deviation. That's my z-score. And the areas that correspond to my 2 z-scores are given right there. And just subtract about a 1/3 chance to get between that many hits. 42 or fewer, less than or equal to 42. Again, x is a hit. X is a hit, so make sure you define that. X equals hits. Z-score of negative 0.77. Again, because I want to be less than or equal to that, I keep that area that the z-score gives me. 48 or more hits. Positive z-score. When I look up 029, my z-score did an area of 0.614. I got to subtract it from 1 because I want to have more than that hit-wise. Okay, rains with probability 0.27 in a certain town on a given March day. Find the probability that the first day it rains is the 5th day of March. And A, this is geometric, A is the x equals the day number of March of first rain. So I want it to rain for the first time, one time, on the 5th day. So the previous 4 days it does not rain. All right? Again, 0.73 is the probability it doesn't rain. That's my answer. Now, it will rain. Find the probability it will rain between 8 and 10 inclusive days this upcoming March. This is not geometric. I want it to rain between 8 and 10 days. So this is a binomial setting. So x is a rainy day. I want the probability that 8's less than or equal to x, which is less than or equal to 10. So that's the probability it rains 8 days. That's the setup. Probability it rains 9 days. Probability it rains 10 days. Okay, add those up. And that's what you get. Again, pause this whenever you need to. And we are going on to our final. Oh, did I lie? I did not lie. That is it. Here's our final question, number 9. This is Poisson, because I give you an average. No probability here. An average of 2.4 glasses are broken each day at a very busy restaurant. Find the probability that a certain day sees 2 or 3. So exactly 2 or exactly 3. There it is. Again, it has an interesting formula. We want to type in the numerator all by itself and divide it by 2 factorial and 3 factorial. That is the probability distribution right there. X is a broken glass. I forgot to write that down. X equals broken glass. Write that down. X equals broken glass. Add them up. There we go. See 0 or 1 broken glasses. All right. Really, you're just taking e to the negative 2.4 because that's 1. That is 1. All right. There we go. And a certain day sees more than 3 broken glasses. So the probability that it's more than 3 is 1 minus the probability that it is 3 or fewer. And I have those answers from above. I have those answers. I did 0, 1, 2, and 3. So I just add the 2 answers from above and subtract it from 1, and there it is. All right, folks, this is Yak Math Videos signing out.